So radical expressions. So radical expressions, right? Radical, that's what we mean when we talk about like the roots. All right, the square root symbol or the cube root symbol, or, you know, whatever, so whatever, so have you there, okay? Any expression that involves those square roots. And then rational exponents. Well, what kind of numbers do we think of when we think of rational numbers? What are those? What's like a rational number? What's a good example of a rational number? Or what's an example of a rational number? Do we know our number sets? So let's think whole numbers. What are the whole numbers? If I look away from Mr. Meyer's eyes, then he won't make me answer. No, just kidding. Like that, no idea what the whole numbers are? Anyone want to hazard a guess? Whole numbers. So, Hunter! Yes! Oh my gosh! Thank you! Yes! Everyone else is like, oh yeah, I was thinking that too. I just didn't want to say it because, you know, I just want to talk. Okay, yeah, so that's the whole numbers, like 1, 2, 3, 4, or you can also call those the counting numbers, or the natural numbers, I guess you want to say too. I don't know if the whole numbers include 0 or not. All right, so those are the whole numbers, and then what are the integers? What are the integers? Integers are Okay, well, the integers include the whole numbers in them, but also has a what? Negatives, yes. Integers are the positive whole numbers, and also then their opposites. So the negatives as well. That's right. Okay, and so then so that's the integers, and then kind of like the next level bigger than that would be the rational numbers. So now with rational numbers, what are we including now? We already have the whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We already have the integers, which is 0, and then all the opposites of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. So what other numbers do we still need to include? Yeah, so and specifically for rational numbers, we have to be a little more like specific. Rational numbers are like repeating decimals, terminating decimals, and then I think that's it. Yeah, repeating decimals and terminating decimals. So for example, pi, it can be written as a decimal, but it never repeats and it never ends. So it's not a rational number. But 1/3, which is 0.3333333, even though it goes on forever, it stops. All right, it doesn't stop, but I mean it repeats itself, so that's fine. So that's 1/3 is a rational number. So basically, one way you can think of a rational number is any number that can be written as a fraction of an integer over an integer. All right. Anywho, so back to radicals though. I always thought it was kind of weird that we call this thing both a radical, but also a root. All right, and so being the inquisitive person that I am, and maybe you guys aren't like this, and maybe this will be completely boring for you, but I think it's interesting. So the word radical comes from the Latin word radix. Okay, and radix, guess what that means in Latin? It means root. Okay, so it's like basically from the Latin, and that's why we call this thing both a root or a radical. There's a vegetable that we also get, radix. Anyone know a vegetable? Yeah, a radish, exactly right. Radishes grow in the ground. They're root vegetables, okay? Don't ask me why we call a carrot a carrot. I don't know. We probably call carrots carrots because someone had already named the orange, and so they're like, what's this thing? Oh, it's orange. That's an orange. And you get the carrots like, crap, so now what? Anyway, that's a joke from who is that makes that joke? Oh, I can't remember his name. I can picture his face now though. Anyway, that's a comedian who does that joke. I was like, that's pretty clever. So I can't take credit for that. Anyway, so there you go. But we're going to look at how we can express a square root using an exponent. So we want to be able to come up with something like this. If we're taking the square root of a, we want to know what is that the same as when we raise it to like an exponent. All right, so we want to know m. We want to figure out this number m here. That's going to be equivalent to doing the square root of a. All right. So we're trying to figure out here this number m, so that when I raise a to that number, it's going to be the same thing as the square root of a. So let's see here. Well, to cancel out a square root, maybe that'll help us here. To cancel out a square root, how do we cancel out square roots? What can we do to both sides? What cancels out a square root? Yeah, square. Let's square both sides. Let's square both sides here. So we'll cancel out that square root. When you square a square root, we'll end up with just a there. All right. And so we know then that a is equal to a to the m to the second power. But then when you have a power raised to a power, how do you simplify those exponents? By doing what? When you have a power raised to a power, how do those exponents simplify? Do we add them? Can I say m plus 2? Are we not sure? Well, let's take a look here. So, if I take 3 squared, what does that mean? It's the same thing as saying what? 3 times 3, right? Okay. If I take 3 squared and then raise that to the third power, well, that's like saying 3 squared times 3 squared times 3 squared, isn't it? Which is then really 3 times 3 times 3 times 3 times 3 times 3, which is 3 to the what? 6. Ooh. So how can we simplify these exponents? When you raise a power to a power, how do they simplify? You multiply them, that's right. Okay. And by the way, folks, if you're like, next semester or next year, whenever you're next in class, and you come to these like exponential kind of questions, and your teacher's like, what do you do? What do you get when you raise a power to a power? And you're like, oh crap, I can never remember this. Am I supposed to add? Am I supposed to multiply? You can just literally like write it out like this. Okay, well I know 3 squared is 3 times 3, so if 3 squared cubed then is going to be 3 squared times 3 squared times 3 squared. You can figure it out. You don't have to like necessarily memorize it, okay? You can actually figure it out. You all are capable of that. Anyway, so yeah, we have a power here raised to a power, so what would that simplify to? A to the m to the 2 is the same thing as a to the what? 2m. All right. Very good. What's the exponent for this a right here, by the way? 1. 1. Okay. So I have a to the 1 is equal to that same a to the 2m. So if that's true, what else could we say is going to be equal? A to the 1 is going to be equal to a to the 2m. So if that's true, what must be equal here? If these two things are equal, and they both have the same base of a, what else must be equal?
Does the 1 have to be equal to 2m?
Yeah, 1 has to equal 2m. Has to. If you have the same base, and the two numbers are the same, that means your exponents have to be the same too. 3 squared can't equal 3 to the third, right? A to the 1 has to, if it's a to 1 equals a to the 2m, then 1 must equal 2m. And if that's the case, then what does m equal? Yeah, 1/2 or 0.5. So, in other words, the square root of a is equal to a to the what exponent? One half. Yeah. You can raise, I don't know, have you guys seen stuff like this before? Have you guys raised things to fractional exponents before? Yeah, so you can do this. You can raise numbers to fractions. And it turns out that they're like they're roots. So 1/2, square root of a is equal to a to the 1/2. All right? So that's kind of like the conclusion there. All right? So roots are like your fractions, your denominators, your fractions. All right, what about the cube root of a? What do you guys predict that power will be? What is that? What's that exponent that we could say? So again, the cube root of a, what do you think that exponent will be here? What will m be, you think? Any ideas? Hunter? 1/3, you think? Okay. Anyone else have something different? Well, let's see here. Let's do the same thing. So let's kind of do the same work, the same argument here. To undo a cube root, what do we do to both sides? Cube it. That's right. So cube both sides there. And so you get a equals, again, a power to a power means it's going to be a to the 3m. Again, that's really just like a to the 1 there. So then what's a new equation that we could write? Julia, what's a new equation we could write here from here? What else could I say? If a to the 1 is equal to a to the 3m, and they're both equal to a, what would I write now? There you go. 1 equals 3m. And then to finish solving for m, what would we do there, Julia? Yeah, m equals 1/3. So there it is. Hunter's right. And I'm sure many of you, hopefully some of you other guys, were thinking the same thing too, or guys and gals, that the cube root of a is really just equal to a to the 1/3. All right, and that's true. That's true. So then, in general, then we can say this, that the nth root of a is equal to a to the, what exponent there, Keegan? The nth root of a would equal a to the what? What power?
The 2n or just n?
Well, so let's go back up here. So this was the square root, which I could put like a little well, let me do it right here. That's like saying the square root of a, right? That was equal to a to the 1/2. The cube root of a was equal to a to the 1/3. So the nth root of a should equal a to the what? Based on what we saw here. 1 over n. 1 over n. 1 over n. So in general, that's going to be true. Okay. All right. So if we take something like, so let me kind of summarize it this way. The exponent, and I'm going to use even more general here, the exponent m over n indicates the mth power of the nth root of a quantity. And I'm going to put in parentheses, or the nth root of the mth power. And it's kind of silly that we use traditionally like m and n there because they sound so alike, but hooray math, okay? All right, so the exponent m to the n, so that algebraically is like this. If I had like a to the m over n power, a to the m over n power, that's going to equal, two ways we could write it. We can say the nth root of a all raised to the m, like that, or we can write it as, I guess I don't really need parentheses there, that's kind of silly, okay. The nth root of the quantity a to the m. These two things are equivalent. They mean this, they're saying the same thing. They're saying the same thing. So a to the m over n is equal to the nth root of a to the m power, or the nth root of a to the m power. And they're the same thing. You can write them equivalently either way. So as an example, with like numbers, because I know all these variables can be kind of confusing, let's say I start with something like 27 to the 2/3 power. Okay, 27 to the 2/3 power. Well, I could write it I could write it this first way as the what root of 27? Let's go to... So Elizabeth, what root would I write for the 27 here? It's the what root of 27? According to my fraction exponent here, what root would the be of the 27? Sorry? Okay, so look at your fraction. M over n. You see how here a is being raised to the m over n power? And then what does it change to? It's the nth root of a to the mth power. So what's our n in this problem? On this expression. What's like the n in this problem? The 3. So that means with the 27, we're going to take what root of 27? Sorry? He's like yelling. So, okay, all right. So again, we're back to this. One more time here. So a to the m over n, right? We have a number raised to a fraction exponent. So just like here, 27 to the 2/3. Our a is like 27. The m is like the... What does that match up to here? What does the m match up to? 2, and the n matches to the 3. Okay, right. So the denominator is 3, and look what happens. The denominator here becomes the root. It's the nth root of a. So in this case, because we have a 3 in our denominator, what root will it be? What's that? 3. Yeah, the cube root. Yeah, it's cube root at 27. All right. Raised to the mth power. So what's that going to be raised to? What exponent? What power then is that going to be right here? 2. Yeah. All right. So what's the cube root of 27? Do you know that is a cube root of 27? It comes out evenly. It's 3. That's right, Keegan. So yeah, it becomes 3 squared, which is then just what? 9. Yeah, so there it is. 27 to the 2/3 is 9. All right, let's try another one. Let's do 4 to the 3/2. All right. Now, we could write this the other way here. All right, so we can do 4 to the 3rd on the inside, and then we can do the square root on the outside. I could put a little 2 there if you want, just to kind of make it more obvious. So you see how we changed it up here. The root, it's still square root, and it's still to the 3rd power, but we flipped the order around. Instead of the cube being on the, instead of the numerator being like the outermost thing, it's now inside. It's now inside. You'll see we end up with the same, well, I'll do it both ways, and you'll see we end up with the same thing. So now we're going to do 4 cubed, which is 64. And the square root of 64 is 8. Okay, now let's do it the other way. Let's flip it around. Let's flip it back to the way I did the first one there. All right, so instead of the square root of 4 cubed, I can write the square root of 4, that quantity cubed. So you see how I changed it around here? I put the square root inside the cube as opposed to the cube inside the square root. But what's the square root of 4? 2. And what's 2 cubed? 8. It's the same thing. Okay, so it doesn't matter which way you put it. You can put you can do the radical first and then raise it to the exponent, or you can raise it to the exponent first and then do the radical. I'll tell you my suggestion. You do the radical first and then you do the cube, and then you do the power, because if you do the power first, you're going to get a really big number, and you have to take the the square root cube root of a really big number, which is harder to remember. But if you do the square root of cube root first, then it can maybe help help get that done. All right. So let's get some more practice with this, because it seems like this is pretty tricky. All right. So let's say so any questions so far? Any questions so far before I move on? I feel like I want to just bust on through here. No questions? We're all good? All right, so let's get some practice with this then. Let's try. So our goal here is to translate, just translate radical expressions into expressions with rational exponents and we're going to say and vice versa. Simplify numeric expressions when possible. Question, Ed?
It's probably the stupidest question of all time, but are we having a quiz on this?
No, we are not.
We're learning it. We haven't checked.
So eventually you'll be tested on this topic because it's going to show up in Algebra 2 for sure. So Stephanie's like, peace, Mr. Witt. No, you really should pay. I mean, if, judging by how tricky this is now, imagine later on when you're really going to have quizzes and tests on this stuff, how tricky it could potentially be. So it'll be a good idea to try and get this stuff down now. That's what my goal is here, to try and help you guys out, trying to get you ready for Algebra 2. Because the Algebra 2 teachers, especially the honors ones, have said that this is, sometimes where students get some difficulty. So I want to make sure that, we set you up for some success here. So, short story, no quiz or tests. So, the pressure's off, so to speak. All right. So now that no one's going to pay attention, since there's no test or quiz.
Sorry.
That's all right. I know. We train you guys. I mean, we train you. That's how we get you to learn. That's how and it's our own fault. We create these little monsters, and I was a monster at one point too, and I still, I guess, am to a certain degree, where we have to have the little carrot dangling out in front of us to I don't really need to learn this because I'm not going to get a grade for it, kind of thing. I get that. I get it. But it will be a carrot eventually, so you can prepare for that carrot, But I understand. All right, so let's try this one. Negative 125 to the 4/3 power. So obviously, this is an expression with a rational exponent, right? Its exponent is a fraction, and we want to turn it into a radical, that is with a root, with a little square root symbol or cube root, whatever that is. All right. So, by the way, what is the root in this case, Mary? What root are we going to be working with according to the exponent here?
The cube root of negative 125.
Yes, exactly right. It is the cube. Yes, exactly right. Very good. Exactly right. We're working with the cube root here. Our denominator is 3, so it's cube root of the number, negative 125, and then that can all be raised to the 4th power. All right. Now, can someone want to volunteer? What's the other way that we could have written this, besides the way that Mary said to write it? What's another way we could have written it, Stephanie? Cube root the whole quantity, yeah, like that. Exactly right. Okay, Evan, did you have a question, or
No.
you want to say what the answer was? Okay, so which one did you go with, Evan? Did you do the first one like Mary said?
Yeah.
Okay, I think that's the better one to go with because it's going to require us to cube and then to the cube root and then 4th power. So what is the cube root of negative 125?
5 or
Negative 5. Negative 5. Yep, and it'll be negative 5 then to the 4th, which is going to yield what?
positive 625?
Positive 625. You got it.
And so just to clarify, it goes to the 3rd, and then it will just become a negative 125.
Oh, right, correct, exactly right. Which makes sense because the cube root and the cube would really just cancel.
Well, I guess it kind of, yeah.
No, but that's good. That's good. Thank you. Okay, wonderful. All right. So now, let's on our calculator, I'll show you that this is going to end up being the same thing as well, because otherwise it's going to be a hot mess. So, cube root of negative 125 to the 4th. Whoop! I forgot to put the 4th. Okay, like that. So there's what Stephanie said to write. Hit enter, and it gives us the exact same 625 that we got with Evan there. So it is the exact same thing. Okay. Now, of course, alternative to writing the root and the 4th power in the first place is I could just take negative 125 and raise it to the fraction 4/3. And there it is as well. So the calculator would do the whole thing for you there in that case. All right. And so, Maria, that's what I was trying to say later, that you don't need to know how to do the square root command. You just do to the 0.5 or to the 1/3, whatever you need for your calculator. And that's true for you all as well. All right, let's try another one. Let's throw in some variables here. X to the 11/8. X to the 11/8. All right. So, John, how can we write this one?
You could write 8 or x. I'm not sure how you say it, but the 8 in front of the x.
Eighth root of x.
And that's to the 11th power.
So the entire quantity to the 11th power. Yep, that's one way to write it. Absolutely right. Can you come up with the other way, John? What would be the other way that we could write that?
You could write that it's 8 to the
You get the root 8, okay, or yeah, 8th root of,
x to the 11th.
yeah, on the inside. Exactly right. Very good. Those are your two options right there to write that. All right, and that's all we had to do there. It's only said to simplify the numeric expressions. There is a way to simplify this, though. Does anyone think we could simplify it here? It's kind of like what Patrick did earlier for the warm-up, or what we saw Patrick do earlier for the warm-up. So you don't have to do that. This is not part, but I'm going to show it to you anyway, just because why not, right? It's not like you're going to get graded on anyway, so you can just tune me out if you want. But x to the 11th is the same thing as x to the 8th times x to the what? To the what? The third. That's right. And so having the 8th root of x to the 11th is the same thing as having the 8th root of x to the 8th times x to the third. Now, why did I pick x to the 8th times x to the third? Well, because x to the 8th will cancel out with the 8th root there, and so that's going to end up being the 8th root of x to the 8th times the 8th root of x to the third. So those will simplify to just x times the 8th root of x to the third. So these are also equivalent too. I guess these are all three equivalent, really. Three different ways to write the same quantity. Well, fourth, I guess you really can count that one there. All right, and so this is part of the reason why like roots and exponents can get so, I think, confusing to students, because you're not really sure which one you're looking for here. Do you want this? Do you want this? Do you want this? I think in our case, it only said to simplify numeric expressions, so since it's not numbers, it's like variables and stuff, you don't have to worry about that. Either these two would be accepted. But later on, when your directions are just like simplify, you're like, well, is it this? Is it this? Is it this? So you'll have to clarify, obviously, get some clarification. All right. I'm going to have you guys try one here. All right, so try the 5th root of 6 to the 4. So obviously you're going to write this one in, equals 6 to the what, basically. That's what you're going to do. Fill in the blank there. All right, and then also try the 4th root of x cubed, and again, that's going to equal x to the what? So take 10 seconds. All right, volunteers for the first one? 6 to the... What's the same thing? So the fifth root of 6 to the fourth is the same thing as 6 to what exponent? No volunteers? What's that? 4 over 5. Whoops, why did I write that? 6 to the 4/5. Yep. The denominator will be the root. The numerator will be the exponent power there. So yep, 6 to the 4/5. Good. All right. How about this one here? The fourth root of x, that quantity raised to the third. What will that become? That's equal to x to the 3/4. That's right, Keegan. You got it. Okay. All right. I'm going to show a few. I'm going to look at a few more here. Then we'll be done. I'm going to say, I think 3 more we'll look at. 3 more. All right. We'll go through a little bit quicker here. 81/16 raised to the 3/4 power. All right. So hopefully now we realize, right, that the 3/4 power, that's the same thing as saying the fraction 81/16, the fourth root of that, and then that quantity cubed. Can we simplify the fourth root of 81/16? Can that be simplified? Tanner?
3/2.
3/2? How'd you get that?
I just plugged into my calculator.
Okay, that works. Yeah, so the fourth root of 81/16, well, 81 is 3 to the fourth. 16 is 2 to the fourth. So the fourth root of 3 to the fourth is 3. The fourth root of 16 to the fourth is 2. The fourth root of 81 is 3. The fourth root of 16 is 2. You can break up division like that. So you can just do the fourth root of 81 and the fourth root of 16 to get 3/2. And then that quantity is going to be raised to the third power still, though. And so then our final answer is going to be what? What's 3/2 cubed equal to? Evan? No decimal. Just give me what would the numerator be, for example? 27 over 8. Yeah, 27/8. Believe it or not, 81/16 to the 3/4 power simplifies nicely to 27/8. You can kind of like break up the numerator and denominator if that helps you. Don't feel like you got to take all the fraction at once, because I know fractions are not necessarily our friends. All right, but there they are. Alrighty, very good. Okay, so we can throw in some variables here too. So for example, like xy to the 5/3 power. Alright, again, we're going to rewrite this. Clearly it's using rational exponents. We want to rewrite that using radicals, so the roots. So how can we redo this one? Let's go to Maria. What do you say here? How can we rewrite this one? What would the root be? Yep. Yeah, what number would I put here? 3. And then what's going to go inside? xy. The whole thing? The whole thing to the 5th. That's one way to write it. Or we could have written the cube root of the quantity xy to the 5th on the inside too. It'll be the same thing. All right. One more here. One more. Last one. Cube root of 11 to the 6th. Cube root of 11 to the 6th. Well, that's equal to 11 to the... What there, Drew?
6/3.
6/3.
Wouldn't that also be 1 squared?
That's a good question. So we know that the normal fraction that we run across, 6 over 3, 6/3, right, that normal fraction, it does simplify to 2. So then does this equal, are they the same thing? Are they? Well, 11 squared we know is 121. Well, we can go to our calculators here. So let's see here. The cube root of 11 to the 6th. Sure enough. So absolutely. You can simplify fractional exponents like that. 6/3 does simplify just like normally, like any other normal fraction does, to 121. So yes, you can simplify exponents like that. Okay? All right. Well, good job there. I know that wasn't the easiest thing in the world. All right. It's kind of confusing, kind of tricky. But that's all we're going to do. Just that. Just making sure we can translate from one to